recording. So for this one, we've got ourselves the is permutation problem. So that's problem 2.4, and that's again checking if two things are permutations of each other. So again, we're going to look at as public static E Boolean is permutation. List of E list A, and I'm just going to call it list A and E list A. Now this helps enforce that basically that these are going to be the same types. We're going to assume that these two things are a permutation, and we're going to try to disprove otherwise. And then what we're going to do over here is that we are going to do if the first thing we're going to check is to see if the sizes are different, because that's a super useful assumption for us to make. If the two sizes are not equal, return false. Okay, first, my mild rant about a design choice in Java I hate. It's one of my few major complaints with Java, which is that it's array.length, string.length with parentheses, and collection, which is what an array list is, and basically everything we're dealing with in this class, it's .size. Python just simply is len for everything, and that gets you the answer you want. And I wish they had just chosen one thing and started with it. I get the design choice, but I don't like it. And so anyway, so first off, if this had been a normal class, I would have told you, you would have had a chance to go home and take a look at this problem and then try to come to class with the solution. And typically what some students do is they're like, how do I check if two permutations things are permutations of each other? They'll see, oh, okay, again, as I mentioned earlier, as I alluded to earlier, you can sort two things, okay? However, and they'll see, okay, the way to sort things is that just like there's an arrays class, that is a bunch of useful arrays method, there's a collections class, that is a bunch of methods for collections, just like lists. And one of them is sort, right? And take in two things, sort A, list B. So I sort list A. I've got to import that. Ignore the error for right now. I'll talk about it in just a second. Sort list B, and essentially return is list A dot equals list B, and this would work if it weren't for that error that I just mentioned. And let's take a look at what our error is over here. And it says collections.sort. So first off, collections again, and you can do this where you can kind of look up the documentation and the code while we're doing it. Ignore over here all this stuff. I'll get into that for a second. It says it sorts the specified list in ascending order according to the natural ordering of its elements. Okay, meaning that the countable order. However, it says we get an error here, and it says required type list of type T, but you provide a list of type E. You're like, oh, okay, fine. The letter must matter, so I'll put in a T here instead. Right? No problem. And then it says I was expecting a list of T's, and you provided T's. And now you're very confused, but it's that bottom text over here that's hard to see. Then I'll read it out. No instances of type variables T exist so that T conforms to comparable question mark super T. Ignore the question mark super T over there. That's not important. That's not relevant to our things. That's a nifty typing feature, but it requires you to understand the whole comparable thing first. So remember what I said about, I think, an hour and a half ago at this point, that sorting lists only works for things that can be sorted, like integers and strings. So we would have to we'd have to enforce that only things that can be sorted are E's. Right now, objects can be anything, like scanners, and how in the world do you sort scanners? Right? So the letter doesn't matter. I'll go back to using E. So here we're saying it's a list of anything, and collections is saying it's anything. I don't know how to sort anything. I only know how to sort things that can be ordered, things that can be put in a natural order. And the way Java can tell you, the way Java informs different parts of the code that things have a natural order is by saying they're comparable. Now, that's over here. A comparable is a very basic interface. Remember, things can inherit an unlimited number of interfaces, and it's got one method, compare to. And what compare to does is that it returns less than, it tells you whether two things are in the correct order, they're equal, or they're swapped around. Specifically what it does is that, let me go to, I'm going to go and create a main method now, PSVM. Don't worry, we're going to fix it to show you, we're going to do this two ways. The easy, like basically this comparable way, and then the manual way. Because the comparables thing is useful to know. Yes?
So can we use contains all? It works quite...
Does it, though? Does it?
If list 2 contains all, list 1, then it just returns true.
Check it for A, B, B, and B, and B, A, A. Sorry. Check it for where they basically try A, B, B, and A, A, B, where basically you have 2 of one in one and 2 of the other in the other one. Test it on there. I think that would fail in that case, because that's just checking whether they exist rather than do they have the same counts. That's what makes this one tricky. Okay. Okay, so here to do compare, so here's an example. All integers are comparable. Integer I is equal to 5. Integer, let's go ahead and use X and Y. That's easy. They're more distinct visually. Is equal to 10. X, and now we're going to print out X dot compare to, was the very first suggestion, Y. And that's going to return, and that's going to print out -1. And so when compare gives you a negative number back, sorry, why isn't it running? Oh, it's building. When compare gives you a negative number back, compare to gives you a negative number, that means that A is less than B, or A comes before B. X comes before Y in this case. If they are equal, in this case, you're going to get a 0. Okay. There we go. And then if A comes after B, or if X is greater than Y in this case, you'll get a positive number. Note that I didn't say -1 and +1. I said negative number and positive number, because you can encode more. That's not the only requirement. If you want to, you can include more information, like in the case of strings, which I find is fascinating, which is if we did apple compared to, let's see, durian, okay, 2 fruits, we'll get -3, which is a negative number. But the information encoded here is the difference in how far apart they are, you know, letter-wise. You know, A comes 3 before D. So you can, so depending on who wrote the function, they included more, or the program, they included more information in there. Okay, so anyway, so that's how compare to works. We aren't going to need to use compare to until we get to all the way to trees, which is like close to the second exam. So don't worry about it. I just figured I'd give you a preview here, give you the same thing I would normally do. So the way we can say, okay, we want things to be here to be comparables, okay, is that we would do extends. So here you can do E extends comparable E. And here what we're saying is that we're enforcing that we've got 2 lists of type E. And what does that mean? It means that they are they are things that are comparable to other things that are exactly the same as that are exactly the same type as them. That's what it's saying. Basically, it says e's that we can sort, and they're only going to sort against other e's. The whole question mark super thing was so that you could like deal with super classes as well, but now it works. That's the short way of doing it.
It contains all works.
That's how it would work. I don't know. I'll check it afterwards. Okay. The other way to do it, though, the way that to do it manually is probably more useful, right? Because actually the way I would normally do this is use a hash map, as I've talked about, but you'll see that later when we do talk about dictionary/hash maps. So over here, rather than, making a bloated statement like this, I'm going to just do it the way that, what we're going to do is that we're going to count them. So the way I'm going to do this is I'm going to do this for each loop. For every item A in list A, for every item in A, I need to count the number of times that I got to do two. This is what makes it annoying. Int count A is equal to 0. Int count B is equal to 0. Going to count the number of times it occurs in A, count the number of times it occurs in B. Or rather, let's go ahead and just call this for every item in A. Count the number of times it occurs in A, count the number of times it occurs in B. And then what we'll do at the end of the for loop is that every time we hit the end, we'll say, hey, if count A and count B are different, then it's not a permutation because we've got different numbers of items here. And if it can pass that for all the items, then we're great. Now, one way to do that, if we're going to be cheap about this, is that we could say, now that I'm thinking about it, let's see, do we have a count method? We have a stream.count. Ugh, okay. In Python, you get count, right? This is why I like Python, but whatever. There's all these stream methods, but honestly, I don't want to have to touch those. So, guess we're going to have to do it manually. For I in list A.size, if list.get if list A, I get the item dot equals item. So if those two items are equal, count A plus plus. Copy. Paste. And now make sure you change all the A's to B's over here. Make sense? So here so this is what makes it unusual, and that's why I wrote it kind of differently on the inside and the outside, so they could be visually different. I have to iterate while on the outer loop. I'm iterating over list A, and I'm iterating over the same loop as an inner loop. Yes.
I was gonna do it a different way.
Mm-hmm.
I was gonna go through the first list and compare it, or see if it's in the second list, and if it is, then remove that from the second list. Yep,
you can. That's another way you can go around doing it, which is that look in the item for each item in it. You go through every item and then you remove it, and then if you can't remove it because it no longer because it doesn't exist, then you've got a mismatch right somewhere. That's a good way to do it. The only disadvantage is that it's destructive. In other words, you have to remove items from the list in order to do it, which is fine. I didn't say you couldn't do that. And I wrote this specifically so that it would not have to touch anything in the original lists.
Well,
you could always clone it too, right? Is what you, huh?
Yeah, I was just gonna say you could create new lists.
Yeah, that's totally fine. There is more than one way to do this problem, and I just showed 2 ways to do this problem. And again, as long as it doesn't have like the worst runtime in the world, like as long as you're not venturing into weird exponential time, I'm going to be fine with that answer. You know, but this is how you do that problem. Check if the sizes are equal, and then, again, over here it's a bit weird because we have to iterate over the outer loop and the inner loop. Sorry, because we've got this, this outer loop and inner loop look exactly the same. It's very annoying. Or rather, we're iterating over the same thing on the inside is being iterated over on the outside as well. And that's just really unusual. You generally don't iterate over the same thing twice. Or if you do, you're iterating over like different subsections of it, like you are with unique. All right, any questions on this one? Any questions on other ones? So how many of you have tried remove all instances? I know you have. How many of you have tried remove all instances? Because if you haven't, I recommend trying remove all instances. Because that one can be a bit tricky. So let me go ahead and stop recording.